Hey folks, 12.2. Okay, 12.2. Test for independence and the homogeneity of proportions. Sounds scary, but no big deal. We're going to be doing more hypothesis tests, and hopefully we're getting used to the game. So they give us some data on this worksheet. We have males and females, Democrat, Republican, Independent, Libertarians. I went ahead and added up the rows, and I added up the columns. And I got 260 total people. Oh, by the way, I'm going to draw a quick picture up here. That's a pretty good picture. Aha, that looks like I think it's called the Parthenon? Acropolis? One of those buildings in Greece. Those are called Greek columns. So columns go vertically. So how many columns do we have here? 4. How many rows do we have here? 2. Oh, so we ignore the totals. Yes, ignore the totals. So our data, it's always rows by columns. This data was given to us as a 2 by 4. And we're going to put it into a matrix, 2 by 4. So I always remember rows by columns with RC. It used to be a soda pop back in the day, RC Cola, rows by columns. Okay, those are my silly mnemonics. And then columns go vertically. See, I got distracted. Okay, so I went ahead and I got the row totals of 110 and 150. I got the column totals of 75, 60, 55, and 70. And then this is called the total, 260. So of the 260 people, they were either male, female, Democrat, Republican, Independent, Libertarian, and they fell into one of these 8 bins. Okay, so now what we're wondering is, if there is no relationship, let's write this down, no relationship, versus there being a relationship. If there's a relationship, it makes sense to me that I could use the word dependent. There's a dependence. Dependent. If there's a relationship, if there's a dependence, then you could say something like, oh, there's a relationship. You tell me the person's gender, and I can tell you what political party they're in. So just to be stereotypical, it's like, oh, it's a female, they're probably Democrat. So that would mean that there's a relationship, a dependence. If there's no relationship, then we would say that the variables are independent. Independent. There is no relationship. Independent. So what we're going to figure out is if gender, male or female, and political affiliation are independent, how many male Democrats should there be? How many male Republicans should there be? How many female independents should there be? So one way you could do that, you could, let's say we want to figure out what goes right here. So what you do is you take the row total times the column total divided by the total total. What? So 75 times 110 divided by 260. Calculator on clear. 75 times 110 divided by 260. Enter. I'm going to show you a shortcut. 31.73. Okay. So how many male Democrats are there? What did we observe? We observed 25. So we have our observations, observed data, 25 male Democrats. But if these ideas are independent, if gender and political affiliation are independent, there should have been 31.73. So in blue here is our expected. And that's expected if independent. Okay. So just for fun, what number would go right here? That would be, so this is the independent females, row total times column total divided by total total. So that would be, I'll just write it right here for no reason, 150 times 55 divided by 260. So let's see, 150 times 55 divided by 260, enter. So we're expecting about 31.73. Again? Coincidence, total coincidence that those numbers were the same. So what we're going to be doing is looking at the observed value relative to the expected. Oh, this one's only 1.73 off. Oh, this one is like, if you subtract them, 6.73 off. Ooh, this one's kind of far away. So if the numbers are all really far away, if all the observed and expecteds are really different from each other, see, these are kind of the same. But if they're all really different, then we would kind of say, oh, something weird is going on. There's probably some sort of relationship. So that's the idea you need to ponder. If the numbers are all, if the observed and expecteds are all really different from each other, then that probably means there's some sort of relationship, some sort of dependence. Okay. Let's figure out a shortcut to getting these numbers. Okay, I'm going to hit clear. I'm going to put all these numbers in black, these observed numbers, into my calculator using a matrix. Hopefully we can see this okay. It says matrix in like blue on my calculator. It's above that button. It's kind of hard to see, but look for the word matrix. You're going to have to hit the second first. So second, and then hit that thing to go to matrix. And in black ink, you see how we agreed earlier, I have a 2x4 of data. So I need to enter a 2x4 matrix. Currently, my calculator says in A, there's a 3x5. So I need to edit that. Slide over to edit, and then number 1 is lit up, so hit enter. And I'm going to change the dimensions of the matrix to 2, enter, 4, enter. And now I can just input the data. So 25, enter, 20, enter, 25, enter, 40, enter. It goes to the next line. 50, enter, 40, enter, 30, enter, 30, enter. Okay, I'm going to pretend like you can see that okay. Okay, so now I have all of that in matrix A. I'm going to jump ahead a little bit. So let's go to stats. We're going to do a test. We're going to learn how to do the chi-squared test. I think it's at the very bottom. Oh, chi-squared test. Not the chi-squared GOF, just the chi-squared. It says x squared. Remember, Greek letter x is chi. Chi rhymes with guy. Don't say chai. That's a T. Chi-squared test. Hit enter. And it says observed. Oh, remember we had our observed values in black ink that we just entered into a matrix? And it says matrix A. Cool. And then it says expected, B. Oh, I didn't do anything in B. I know. Your calculator is going to figure it all out for us. Okay, so let's just leave that alone and slide down to calculate and hit enter. Oh, and it does some weird chi-squared statistic and a p. Oh, a p-value and a degrees of freedom. We'll talk about that in a second. But apparently my calculator made the expected matrix B. Let's see if that's true. So hit clear. So go back to matrix. And then, oh, B is now a 2x4 matrix. Slide down. Hit enter, it says matrix B, and then hit enter again, it'll show you the numbers. Oh, snap, 31.73, 43.2, about 7, and then, is it going to slide over well? I don't know. Only I knew how to use my calculator. Here's another way you can do it. So I'm having trouble. If I know how to use my calculator, I could probably slide over. But if I go back to matrix, so matrix, slide down to B. First slide to edit. Then slide down to B. Aha. Oh, now I can see all the numbers. Okay. 25 point about 39, 34 about 62. Go down into the matrix. Slide over. Yep, 31.73 was right. 23.269. 29.615. And 40.385. every once in a while in the book or on a test, they'll say, oh, how many female Republicans would you be expecting? So you could just use the matrix to figure it out really quickly, 34.62. Or you could have just said 60 times 150 divided by 260. That would have given us 34.62 also. Okay. I think that's our warm-up. So we have all the data entered into our matrix, and then on the next page, they want us to actually do a hypothesis test. Okay. So, oh, one more thing. Notice there are minimum requirements. At the very bottom, it says, in order to use the chi-square distribution, the following minimum requirements must be met. Oftentimes when you read a problem in the book or that I wrote, it'll just say, assume minimum requirements are met. See, none of the expected frequencies is less than 1. So make sure none of those numbers is less than 1. Okay, so no zeros. And at most, 20% of the expected frequencies are less than 5. Well, none of them are less than 5, so we're good. Okay, and then let's take a look at that formula for 1 second. The chi-squared formula, we're going to, as you saw before, the calculator is just going to magically figure it out for us. But the chi-squared is just the summation, that's not 0, that's O, of the observed minus the expected quantity squared divided by the expected. So imagine this, if you will. So go to the first cell. 25 is our observed. 31.73 is our expected. So I would do 25 minus 31.73 squared divided by 31.73. Summation. Go to the next square. 20. Oh my gosh, I'm not going to do this. 25.39 squared divided by 25.39. Summation plus. So I do it with those two, those two, those two, those two, them. And then I do all that, and it's going to give me my chi-squared value. But as we saw a minute ago, the calculator does it all for us magically. Okay, so we'll take a little break right here, and then we're going to start page 2 in the next video.